No, we got disconnected, right? So now, mm, so so as I said, right, even a lot of other companies, no, they also started pulling their hands from this project, and the project was stopped. It was failed, and they couldn't come up with the solution of developing this multitasking in the multi-user operating system, right? So later, after some point of time, what Dennis Ritchie and Ken Thompson, they thought that, uh, guys, I'm sharing my screen. Are you able to see my screen?
Yeah, yeah, able to see Rajesh.
Okay, okay, great. Thank you. Yeah. So again, what happened, right? These two people, Dennis Ritchie and Ken Thompson, these two, they are great friends. What they thought that let us restart working the project by our own. So by their self-interest, they took that project. Initially, what they did, right? Dennis Ritchie and Ken Thompson, they started working on some space program actually, working on some space, not program, but some space game actually. They started working on some space game. So during working on that space game, they came to know about lot of information about the operating system. Finally, they started working, coding, started working on the development of that operating system. And later, after some point of time, what happened, that they came with a new operating system, which they called as a Unix operating system, which they called it as a Unix operating system. See, the whole design or the architecture of the operating system was done by the Ken Thompson itself. He's a guy, he's a master behind to come up with the whole Unix operating system concept. It means that the whole design of the entire operating system. Okay. Dennis Ritchie also was also a part of development. But what was the greatest contribution from the Dennis Ritchie is that actually that he had, see, let me come back later actually. So once they came up with this Unix operating system. But this Unix operating system, it is not a production environment operating system. It was not a production environment. Means that you cannot take this operating system and deploy into this production server. No, it is not into that state. Why? Because this complete Unix operating system, initially in those days, right, when it was developed, it was developed or it was written, it was developed or written in assembly level language. So it means that the whole code, the complete code of the operating system, was in assembly level language itself, right? Because of which, what happened that if anyone want to understand how this Unix operating system works, first they have to understand about the assembly level coding. They want to understand the code, and then they need to learn, or then they need to understand the operating system, which was very difficult because learning through assembly level language is very difficult. So it means that actually that whole Unix operating system, what happened that the readability was not good, was not good, right? Now, because this operating system, they had ported. So after they wrote it, right, they ported portability. They ported actually into. I have forgotten that name of that that server or the processor, but they ported into that processor actually, and they had built that operating system for that particular processor. Okay. So now what happened? So since they had written the code and they have built into that processor, you cannot take the same operating system and you cannot port into some other processor. So it was non-portable, non-portable, portable. It means that you cannot port, you cannot take this operating system, port into some other architecture like x86 architecture, IS64 architecture, Sparks architecture, right? Or RISC architecture. You cannot take this operating system to some other architecture and deploy it. It was not possible. I'm telling you about the first operating system design, right? Which was completely written in assembly language, right? That was not portable. So what happened? There are a lot of disadvantages were there actually in this operating system because it was a very it was a very elementary or the first release of the operating system, right? Which they worked on it. Who? Dennis Ritchie and Ken Thompson, right? So then what happened? It was not portable. Okay, it was not readability because everything was written in assembly language. Understandability was not good. There was no modularity. No modularity. No modularity in sense. What is it? It means that they have written the whole operating system. It is like in a single file, big file, some 20,000 or 1 lakh line of code. They have written in one single file. They are not divided the whole code into different files or into different modules, right? They didn't divide it like that. So it was like a single file. So modularity was also not good. It means that if any one line of a code of that file, no, if it get fails, the whole program will get failed. You will not be able to execute the program itself, right? So in that way, the modularity also was not good. So all kind of a disadvantages was there in the first release of the operating system. Hence, what happened? It was not a production environment operating system. It was not a production level operating system, right? So that was the disadvantage. Now later what happened, right? Um Later what happened? Dennis Ritchie, like he is a derivative of the C language. So he is the one guy who developed the C language, right? So like before the C language, actually there were many other language. Like you had something like Fortran language, or you had a B language, you had a Fortran language. Now we are not using the Fortran language and all, right? So what this person did, right, Dennis Ritchie, he completely went through the B language, and there were a lot of limitations in the B language. To overcome that, he designed the C language. If you ask me what was the major limitations of the B language, right? B language, B language, it it didn't had the concept of pointers. So what Dennis Ritchie did, he brought this pointer concept, okay, right, right. He bought the pointer functions as well as many other things he derived, like function pointers, point to the functions, structure pointer, point to the structure. He used heavily the linked list, graphs, right. Many of the very core programming concepts which he had adapted in the which he developed in C language, right. That was used to rewrite the operating system. So what Dennis Ritchie did that he understood the complete code of the operating system which was written in assembly language. Now what he thought that let me rewrite the whole source code of the Unix operating system in the C language. So that is the biggest contribution where Dennis Ritchie did actually. Dennis Ritchie, what he did that the complete Unix operating system which was earlier written in assembly level language was in GUAG language, which was written in the assembly language. He means Dennis Ritchie rewrote the whole code in C language. So when he wrote the C language, when he designed it, he made it very clear that tomorrow somebody want to read or go through the whole code, it should be very well modularized manner. So he maintained that modularity concept. He maintained he maintained the readability concept very well, right? As well as he also maintained so that the same Unix operating system which is right, it should be even portable also. It means that I should write a code in such a way that the whole Unix can be even deployed or it can be ported into any other architecture also. Any other process architecture also you can do a porting. It should support actually. That's what he kept in his mind and is written. And as you know that in C language, all kind of a stuff like function pointers, right? Structure pointers. So first you need to have structure pointers, right? Pointers, variables, pointer variables, right? And you have a lot of data structures like linked list, stack, queues, graphs. So these are all heavily used for writing the code of the Unix operating system. Now, what happened when Dennis Ritchie wrote the complete operating system in the C language and he rewrote it, everything, finally he tested it, everything. So, what happened in the year 1975? A very robust and production environment based operating system was released actually. When this came to the market, it was a big blow to everyone. Everyone were interested to understand what is this Unix operating system is all about, how to work on it. So what these people did, right? They created a lot of documents, a lot of manuals. They created a lot of documents, documents, manuals, many other steps. They wrote everything, and finally they started distributing. What they did, what the AT&T did, what the AT&T did, right? They took this complete Unix operating system, the completely Unix operating system. What the AT&T lab did, no? See, there was a lot of effort which has been put by Ken Thompson and Dennis Ritchie, right? Now, but what is the biggest mistake what AT&T lab did at that time is that actually what they did, they took the whole Unix source code, they took it and they started giving into many of the organizations, many of the companies or organizations. So what they did, no, they initially gave to some universities. They gave the source code to universities. I think you might have heard about Berkeley software distribution. Berkeley software distribution. That is one of the organizations. So they gave the whole code of the Unix to the Berkeley software distribution, right? You call it a BSD, because BSD Unix, co-Unix we say, BSD, right? And afterwards they gave to many of the companies, like they gave the source code to IBM, they gave the source code to HP, right? Many other different, they gave the source code to Sun Microsystem company also, okay? So Sun Microsystem, now it is not there because Sun Microsystem was long back acquired by Oracle company, right? And the Sun Microsystem, one of the co-founder of the Sun Microsystem is Bill Joy. He's a guy who is one of the co-founders. There are two co-founders. One of them is a Bill Joy. He is a great scientist or the great person who was a part of AT&T lab. He was a student there. He's a part of AT&T lab. This Bill Joy is the same guy who developed your V editor. In Linux you are using V editor or Vim editor. He is the guy who developed this Vim editor and many other tools and all he had developed. Many of the libraries, lot of stuff he had developed, and he is also one of the co-founder of the Sun Microsystem company, which was acquired by Oracle long back. Not now, sir. It is around, if I'm not wrong, around 10 to 12 years back it was acquired actually. More than that actually, 15 years back it was acquired. Now, what this AT&T lab did, right? They started selling the source code of this Unix operating system to many of the universities, colleges, many of the different organizations like IBM, HP, Sun Microsystem, and all. They started giving this source code to them just for $10, just for a minimal of $10 they used to give. And what the biggest thing happened, right? What is the biggest thing happened that HP, they took the Unix source code, they tried to tweak that code. They learned what is that code, all it does actually. They understood very well. All subsystem of the operating system, like process management, memory management, file management, device management, network management. They studied everything, sir. They got to know about each and every subsystem of the operating system or the kernel. Then what this person did know, they tweaked the code actually. Tweaked the code. And they came up, HP came with came up with its own operating system, which they called as a HPUX operating system. And what they did, right? What HP company did, they started selling this HPUX to other companies without the source code. They didn't give any source code. Without the source code, they started giving this operating system to other companies without the code for $100. Similarly, what happened, right? IBM, it came up with own operating system known as IBM X. Sun Microsystem came up with their own operating system. They called it the Solaris. See, this Solaris, IBM X, HPUX, these are all different variants or different versions or variants of Unix operating system. Guys, you have, I think you have heard one proverb actually. If you are stealing something, right, that will not exist for a very long time, right? If you steal something, that will not exist for a very long time, and that's a true saying. Why? Because, right, all these companies where designed they came up with their own Unix, even though there were massive operating system, this was very good actually, very massive. I mean, the understanding the working of this operating system were very complex actually. Okay, even HPUX, personally I worked on HPUX because I was part of a HP company. So it was such a massive operating system that actually very, very huge applications. Like, for example, if I say, right, if you go to the Bombay Stock Exchange, New York Stock Exchange. It's no, right? In the Bombay Stock Exchange or the New York Stock Exchange, it is not one few, bytes of data. There are terabytes of data will be posted into the dashboard, right? What is the share? What is the share value going? So much huge data transaction is happening in the back end. All were Unix operating system itself actually, means HPX operating system. Similarly, like that, many of the critical applications, everything, they were working on the IBM AX operating system. Similarly, many of the complex applications, huge application, which requires a lot of computing system, they were working on Solaris. But now the time has come, or the days have changed, where these Unix operating system variants have been obsolete. Now, most of these Unix variants are obsolete. It means that they are no more used. They have decommissioned it. Nowhere it is used. It has been obsolete actually, right? Even though it has so much features, what was the requirement that it has to get obsolete? It means that IBM, they said no more. IBM said that we are not doing any more development activity on IBM AX. We are stopping it. So what IBM did now? IBM turned into using Linux. Similarly, HPUX, they said that okay, HP, it's not only HPUX, sir. There are many other operating systems which it developed actually. So even I have forgotten something like they have developed some TrueX actually. TrueX is there. Even I've forgotten. I knew about some six or four or five operating system, but I have forgotten now. They have developed, and almost all the six operating systems it got obsolete now. HP itself, they have stopped working. It long back, not now, like 2009 only they stopped working on HPX, right? It means that no more development on HPX operating system. They stopped it actually. Even in the customer side where they were using HPX, right? What happened, right? Whenever a customer he needs some service from the HP, right? What HP is to say, right? We will give all the solution to you, but you have to purchase our HPX operating system. And this HPX operating system will only work on that particular Superdome server, and we will give the server to you. So HP used to charge. HP is to charge. They used to charge for hardware, for the operating system licensing, and the software licensing, and finally for the software support. See, so many things they used to charge. Same thing like for even with IBM also. Same thing like that even with Sun Microsystems Solaris. So now what happened, right? Many of the customers were paying hefty amount for only for licensing costs, sir. Only to run their small application, they want to change. If they want to they want to procure the hardware from the HP itself. They want to take the OS licensing, which is HPX, even the software licensing also, right? Right, even the software support also. So they were hugely charged from the HP company. So that's how HP company and IBM and Sun, they made a lot of billions of dollars from this actually. Okay, now now that, as I said, right now the days have come, right, where this companies, IBM, HP, or even now Oracle company, they started using Linux operating system now. And Linux is a freeware, it's a free operating system, right? Now, so you understood, right? Now, similarly, what happened, right? You have a Berkeley software distribution, BSD, Berkeley software distribution. They came with their own Unix variant known as a Berkeley BSD Unix, BSD Unix 1, BSD Unix 2, like that. They came with the different variants of operating system. Now, I think no more, nobody's using a Berkeley software distribution Unix, sir. Nobody's using, even nobody's using HPUX or even the Unix, traditional Unix operating system, right? Nowadays, nobody's using it. So that's what I would say, that actually don't use any Unix operating system. There are no Unix operating system these days. It has been obsolete. Almost all the companies who are working on traditionally on Solaris or in IBM X or in HPUX, they are they slowly started migrating to Linux, because the company itself, because the customer base, right, they don't want their software to be run under this operating system. There is a customer requirement is that no, we don't want the same software whatever you are giving, HP's provide, right? They say that we don't want in HPUX, we want everything in Linux operating system. So that's what even this company were forced to migrate their application from the traditional operating system to the Linux operating system. Like for example, if you have EMC company, in the EMC, there are many products are there, sir, which were working on Polaris. Slowly, what happened? No, they all started migrating from Solaris to Linux. It means that those products which were developed particularly for the Solaris operating system, the EMC company told the developers that whatever the softwares or the product you have, you rewrite the whole code so that the whole code will work on Linux operating system. So now what happened? The developers, what they did, right? They did everything. They changed the whole source code of their products, everything to the Linux operating system, and they started migrate. They started testing. They started migrate to Linux. They tested it, and now they said, okay, now it is working fine, and they started giving this product solutions to their end customer now. So now it means that almost every companies they started moving from the traditional Unix to the Linux. Almost nowadays, I don't think any of them. No, some companies do have some old legacy, Unix variant, but slowly they will try to move to Linux now. Okay, so that's how the history. So now what is happening is that so these are the various different Unix variants, but we need not to learn it. Okay, I was very fortunate that I worked on HPUX for some time. I worked even on IBMX. To some extent, I even worked on Solaris also. So it was a good for me that I have worked on the different flavors of Unix variants actually. Okay. So, but for us, it is not really required because we can directly learn Linux itself from the scratch actually. And so this is what all about the history, sir. Okay. So so what happened after some point of time? What the AT&T did, right? They know that they got to know that okay, we are selling the source code to the other company for $10, but by using our code, they are coming with their own Unix variant for $100, and sorry, Unix variant, and they are started selling to other company for $100, right? They were making money out of it, not the AT&T lab. AT&T lab was in a big loss, right? Because they developed the source code or they developed the operating system. Finally, other companies are making benefit out of it, right? It was a kind of a harassment was going on onto the AT&T lab. So after some point of time, Unix, the AT&T, they stopped selling the source code of Unix to the other companies. It is not required. They thought that okay, enough is enough. We have already given source code to outside world. Okay, now we will not give any kind of a code. So they stopped it, and they didn't share any Unix operating system source code to some other companies after some point of time. They stopped selling the source code. But you know that by the time already the source code was used by many other companies, that they tweaked the source code also to come up with their own Unix variant, right? That was already into the picture, right? Fine. So AT&T stopped selling the source code, right, after some point of time. Now what happened, right? So after all this, what has happened? There was a guy who was a student at MIT, Manchester of Technology. His name was Richard Stallman. Guys, have you heard about Richard Stallman? Any chance? Have you heard the name Richard Stallman? There's any idea? No? So, say yes or no.
No, Rajesh.
No, okay. No, Richard Stallman, he was a student of MIT. Okay, he saw that there were a lot of harassment that was going on AT&T Lab because AT&T Lab is a AT&T Lab means within AT&T Lab, Dennis Rich and Ken Thompson. These were the two scientists, right? They designed this Unix operating system, and by mistake they started selling the source code to other company, and other company were making out of benefit out of it. So this Richard Stallman, what he thought that there a lot of harassment was going on, and other companies were making benefit out of it. Even these companies, HPUX and IBMX, they never shared the source code of those Unix variant. If you go and ask to the Sun Microsystem earlier, sir, can I see the source code of Solaris? They'll say no. Why we have to give the source code of Solaris? Why you have to see? Sir, have you seen the source code of the Windows operating system? Anyone? Means Windows Windows operating system. You know that it was developed by Microsoft company, right? Microsoft company. And the key behind the release or the design and release of the Windows operating system, you know that it was a Bill Gates, correct? So, but have you seen that Bill Gates started selling the source code to other companies of Microsoft operating system? No, right? He knows that somebody will misuse my code. So hence what happened that they never sell the source code. Even Solaris was not sold by Sun Microsystem. HP never gave any source code to any other companies or any other organization also, right? So what Richard Stallman saw that other companies are making benefit out of it, and they are not even showing their source code. They are not. They are making it very privacy. So what Richard Stallman thought that okay, fine. He did what he did. No, he quit from the MIT. and he started his own organization. He calls the Free Software Foundation. It's all very important, sir, to understand or to know. Free Software Foundation. In short, we call it FSF. Free Software Foundation. So what he said that, okay, he has come up with his own foundation. He calls it Free Software Foundation. What he said that, okay, today I'm developing certain things. Suppose I'm a scientist or I'm an engineer. I'm developing some source code, or I'm developing some application, or I'm working on some project. Okay, if I will, I can give my source code to the free software founders so that my code is freely available. It means that if you are willing, suppose you have developed a project, you can put your whole project or source code under the free software founders such that it is easily available. It is easily available. It means that your code is free of cost. Means anybody can download your code, download the code. Anybody can go through the code or understand the code, go to the code, and even they have the right to modify the code and put back the same back modified code back to the free software foundation. So it means that everything is freely available. Anybody can download the code, anybody can put your code, anybody can download, go through the code, modify the code, put back the same modified code back to the free software foundation such that it will increase the creativity. It will increase the creativity. So that was the philosophy of this Richard Stallman. So that's what he found this organization as a free software foundation. So he's the same guy, Richard Stallman, who termed the key known as open source. We say, right, open Linux is an open source, man. Jenkins is an open source. Docker is an open source, right? We say this word open source, right? This word open source key was termed or was given by Richard Stallman itself. He's a guy who has given this. If you want to see his picture, see, come here. Richard Stallman. Okay. Open source. Something can give. See, he's a genuine. I will tell about what is genuine. See, he's a guy actually. Big mustache. See, he's a guy. And he's a very close friend of Linus Torvalds also. Okay, he started the free software movement of free software foundation. So you can go through it. It's a very good way, very good learning for you. You can understand his contribution, this guy's contribution. Okay, Richard Stallman. Okay, now, so why he did all these things? Because, right, because anybody can download the code, anybody can put the code. So if you're doing it, actually, you will increase the creativity. That was a theory, or that was a philosophy of this Richard Stallman. So this same person, Richard Stallman, right, at that time, he had developed the Richard Stallman, right? Richard Stallman, he had developed the complete GCC compiler. You know the compiler, right? GCC compiler. Have you heard about compilers? So compiler, we will discuss what is a compiler later on. He's a guy who designed this completely GCC compiler, guys, and he's the first person who had put this completely GCC compiler under the Free Software Foundation, so that anybody can download the whole compiler code and they can learn, they can go through, they can understand the design, they can understand the working design of it, how it works, and finally they can even execute it. And even if they are willing, they can even modify the code also according to the requirement. So he was such a great person. The whole life, what he had worked on designing this completely GCC, he had put in the Free Software Foundation so that anybody can download, anybody can modify, anybody can even they can compile some other program code using GCC compiler. That was the biggest contribution which was done by Richard Stallman. So when he uploaded this entire code into the Free Software Foundation, right, there was a very big bang happened during that time in 1980s, 85 actually, because so many people, they know about what is a compiler, but they doesn't know how it internally works. But this guy, Richard Stallman, he had put a source code, right? Everyone started downloading the code. Everyone are going through the code line by line. They're trying to understand. They got to know the complete design about how exactly the compiler works. So that's what the biggest contribution. And Richard Stallman had also written a lot of standard libraries. Also, a lot of standard libraries were written by him. What is the libraries and all? We'll see later. Okay, a lot of many of the small tools were written actually. But what is the thing? What he did right? Richard Stallman, everything he had posted everything under the Free Software Foundation, guys. But Richard Stallman, what he did, he created one more sub organization within the Free Software Foundation, sub organization, which he called as a GNU organization. GNU is an acronym. GNU stands for GNUs, not Unix actually. So he said that actually it is a GNU is not Unix. It's a never-ending acronym. If you call GNU, GNU is not. What is GNU? Again, GNU not. It's a never-ending acronym. So this is a sub-organization GNU which was formed within the Free Software Foundation. So during that time, what he did right, he had put his DCC compiler, the code of the compiler under the GNU organization. There were many of the tool were there. You know about in the Linux, the Bash is a default shell, right? Bash shell was also part of the GNU organization. Many of the great engineers they together they created one shell and they call the Bash shell. And that Bash shell also they made as a part of the GNU organization so that anybody can download the Bash shell. They can go to the code. They can download the whole code. So that was and many of the other tools like Flex tool, Yak tool, many of the other tools and standard libraries, many things were part of this GNU organization, sir. GNU sub organization. But you could see that there were a lot of tools were there, compilers was there, okay, many other standard libraries was there. But one thing was missing was an operating system. So till that time, there was no operating system, sir. No free operating system which can fill up the gap between everything was there except operating system, everything was there. Correct? So this was one part of the story. So Richard Stallman actually he started this Free Software Foundation. Now what has happened, right? During 1985 or 89, actually, during that time, what happened when this Richard Stallman, when we came up with the Free Software Foundation, the biggest rivalry or the biggest rivalry for this person, Richard Stallman, was Bill Gates. He was very much against with this theory. What he says, open source. He didn't. Bill Gates never liked this term open source, sir. Because what Bill Gates said that our great scientists or engineers they do so much hard work to develop a code, right? Why we need to give the source code or freely to everyone? What is the benefit you are going to get out of from that? That was Bill Gates saying. But Richard was Stallman also was against of the Bill Gates concept because Bill Gates what he said that oh we have to make the money, we have developed the source code like Microsoft. See how it is used everywhere, right? As a desktops, right? Even like for every kind of stuff, Windows is used, but he is never give the source code to any other person, right? Any other persons, any other organization shouldn't come up with the same variant of Unix operating, Windows operating system, right? So they are very much against of this theory. But what Richard Stallman said that there is no wrong in giving the code source code freely because you need to give a flexibility for the customer for any other person so that he can go to the code and modify the code. So you need to have some kind of creativity. That's the reason Richard Stallman he had come up with this open source concept actually. But still, it was a never-ending debate because both were actually debating each other. In many of the conferences, they were both called and they were allowed to talk each other. And Bill Gates was keeping his point, Richard Stallman was keeping his points, and some of the things where Richard Stallman was not agreeing with Bill Gates, there was a never-ending debate was going on. Still today, also the debate is going on, but it is never-ending. But what happened, right? You could see that actually because of this open source concept, right? Many of us, like engineers like us, or many of the people like that, us were able to learn many of the softwares, right? If it is a not open source, if it is a licensing, oh, suppose you want to install Linux on your machine, you have to buy the licensing cost, right? I want to install my Bash shell. Oh, you want to take you have to install it. Oh, I want to build some Jenkins. You have to install. Suppose Jenkins is not an open source, it is a license, so you have to install. You would have never practiced any kind of a tools, right? Without the licensing cost, right? Where will have the money to give the no? Where will have money to no buy for all the softwares and practices? It was not possible. It was very difficult. So I would still say that actually Richard Stallman did a very great thing by coming up with this open source concept and with the Free Software Foundation, right? So that's what. Now that's the reason you see that because of his vision, now you could see that there were so many companies are there which they are working purely on open source tools only. Have you seen any company going with any kind of a like proprietary software or proprietary? No, they will see that, oh, how much I can no, reduce the cost. I should not go with any kind of a proprietary software. Still, many companies are there who are only going with open source only, no proprietary, no licensing cost. If there is a if there is a way that you cannot come out from that, okay, I cannot use any kind of open source for my project, I have to go for a paid version, then only they'll go for paid version. Otherwise they will see maximum they'll try to avoid by paying any kind of a licensing cost. See, even today, even Microsoft also, they are also using many tools internally in the Microsoft which are open source tools only, right? So that's the reason. See, if the person had not vision, we would have not come to know about we would have not come to know about the whole software working itself. So we need to be very much thankful to this guy who came up with this open source concept. Okay. So now what happened, right? As I said, right, in his foundation, there's one more sub organization we call it GNU. Everything was there, sir, but one thing was missing was an operating system. Fine. So this is one part of the story. Okay, one half of the story. Okay. Now other part of the story, a nice part of the story is that in the year 1991, there was a person by name Linux Benedict Torvalds, Torvalds, who was a engineering student, means particularly he was a computer science engineer. Okay, he is from Finland actually, Finland, and and uh, studying in Helsinki University. You know, like in the Finland, there is a, I think the capital of Finland is Helsinki only, if I'm not wrong. University. Helsinki is one of the leaf actually in the Finland, if I'm not wrong. It's like it's a leaf, one of the leaf in Finland. So that's what they call. Sorry, this Helsinki is one of the one of the leaf name in Finland. So there is a university also known as a Helsinki University. So he was a student at the Helsinki University, and he was into his final year of engineering. So, as a for the development of a project or to showcase a project, what Linus Torvalds did, right? He was working on a project. Project means he was basically working on an application, and he was trying to execute that application or try to make that application work under the Minix operating system. So Minix operating system, there was now we don't have any Minix operating system, but earlier during 90s, Minix operating system was there. This was called as a miniature operating system, or we call it a very small operating system, sir. And this Minix operating system, which was designed by a person named Andrew Tannenbaum. I think some of you have heard his name, Andrew Tannenbaum. He's the same guy who has written the data structures books. You might have seen that there are many books out there which were written by C data structures by Andrew Tannenbaum, networking books, networking concept books by Andrew Tannenbaum. Networking concept. So Andrew Tannenbaum, by profession, he's a professor. Just to show his students how the operating system works, he designed this Minix operating system. He designed the Minix operating system. Just to show in the class, okay, how the operating system works and everything. He has designed it. He had ported that operating system into some hardware, some processor, and in the session or in the classes, right, he used to show to students, see how it works like that. So what this fellow Linus Torvalds, right? He had designed an application which he want to port into the Minix operating system, but there was some complication in his application, and which was not able to properly run under the Minix operating system, right? So there was some kind of portability issue, or else it could be some kind of a issue with the coding, or it was a portability issue, or it could be a problem with the Minix operating system itself. It was not supporting his application to get executed. So Relay Torvalds, as a final year project, when he was working on an application, right, it was not able to run properly. So he thought that he understood, he tried to understand that why it is not working. Later he found that, oh, there is some issue with the Linux operating system itself. So what Linus Torvalds did, Benedict Torvalds did that, he approached this Andrew Tannenbaum. He requested over the email, sir, can you please share the Linux source code operating system to me? Because my application is not getting executed properly. I feel like there is some issue with the Linux operating system. I need to do some code changes into the operating system itself so that I can make my application run. But Andrew Tannenbaum replied over the email to the Linus Torvalds, not Linux actually, Linus Torvalds, that why I need to share my code to you, man? Who are you to ask the code to me? Why I need to share to you? So Andrew Tannenbaum never shared the source code of the Minix operating system to Linus Torvalds. Now Linus Torvalds was very much disappointed because he wanted to showcase this project as a final engineering student, right? He wanted to showcase his project, but he couldn't come up with that. Later, what Linus Torvalds thought that, okay, fine, man, leave it. I don't want your Linux operating system. Let me write my own operating system from scratch itself. So what this person did actually, Linus Torvalds, he understood how the Unix operating system works. Actually, he was understanding how this Unix operating system works. Okay, and also, guys, during that time, right, when the Unix operating system was released in 1975, a production-based operating system was released. In the market, there were not many books, or there were no author who used to write a book on the Unix operating system, because most of the companies, they were referring only to some manuals or from documents which was released by AT&T Lab only. So they were referring to those manuals, labs, and all those things only. They were referring to understand about how Unix operating system works. But the very first book which came into the market, right, was, like, there's a book, if you have seen, the design of Unix operating system by Maurice J. Batch. This was a one full fine book, guys. In 90s and all, when 1990s, 95 and all, when people were learning Unix operating system, they used to refer this book only. In the market, this was the most popular book which was available during that time. So people used to go and buy in the market Maurice J. Back book. Give me Maurice J. Back book. It's a brown color front page. Okay, they used to buy it and they start reading the whole Unix operating system by reading this. Now, what this person did, Linus Torvalds, right? Linus Torvalds, he referred to the book by Maurice J. Back, and he had some idea about the operating system. He started writing the code of the operating system from the scratch itself, actually. So initially, you know, initially, just for a fun, just for the fun, he was writing the code. He was writing the code. But ultimately, after some point of time, sir, the project ultimately after some point of time, his work went into a very serious state actually. What this fellow used to do, no, Linus Torvalds, he used to write the code, and the same day he used to post that code into the net, actually, internet. During that day, internet was there. Internet came into the picture, right? 1985 or 87 only the internet came into the picture. So World Wide Web, WWW, right? That came into the picture. 1992, yes, people were using web for their own, message exchanges. They were using the emails exchanges, right? So what he did, right, he used to post the whole code of what has written into the net or into some forum. There were many other people were there in that forum. What they did, right, they were going, or they were understanding the code which was written by Linus Torvalds, and they used to give some suggestions, they used to give some improvements, or they used to even, some of them even used to rewrote his code again. They used to give back the code saying that, oh, it should be like this but not like this. So it was every day he was writing the code and posting the code into the net, and lot of people know, they started liking his way of writing a code and everything. Finally, what happened, right, this same guy Linus Torvalds, in just a 21-year-old, he's just a 20-year-old, he rewrote, he had written the complete operating system code in just 10 months. Okay. So he had designed a complete operating system in just the 10 months of his tenure, actually. And then what this fellow did is that actually he when he wrote the whole code, actually, what Linus Torvalds thought that I need to put my code under the Free Software Foundation or under the GNU organization. Why Linus Torvalds want to put? Because Linus Torvalds, he was very much impressed with the Richard Stallman theory. What Richard Stallman says, everything is free label, anybody can download the code, anybody can modify the code, anybody can put the code. He was very much impressed with his theory. That's the reason what happened. Linus Torvalds, when he thought, okay, see, there was one more thing, guys. One more thing. What happened when Linus Torvalds approached many of the times to Annie Baum to share the source code, but this person never shared the source code at all, the Unix operating system, because Linux servers become very bad. He felt very bad. Why this person is not sharing the source code? Then he thought himself that okay, tomorrow I will try to develop my own code, man. Whatever I will develop my own code, I will make it as a free software. I will make it as a free, so that anybody can download my code, anybody can use my code, or anybody can use my operating system or the code for their own benefit. They can use. That is where he interacted with this Richard Stallman, and he was very much impressed with his theories. That's what Linus Torvalds thought that, hey, whatever I develop tomorrow, I need to put under the GNU organization or I need to put under the Free Software Foundation. He thought from the day first onwards when he started writing or when he started developing the code. That's the reason what happened, right? What Linus Torvalds thought that, let me keep the operating system name as Freaks because it is freely available. Freaks means actually it is free. IX means actually it is like a Unix variant or it's like a ditto like a Unix. That's what he want to keep the name as a Freaks. But what happened during after the 10 months, like many of the people became a follower of the Linux Torvalds actually. They said, no, 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 don't keep the name as Linus. Instead, keep the name as Linux. Here his name is Linus. Just replace this S with X. That's all. But even what happened, even after that also, what happened, right? Linus Torvalds never agreed to keep the name as Linux. He want to still keep the name as a Freaks, but because there was a lot of pressure from his followers and friends and all, finally he agreed to keep the name as Linux actually. Okay, and what he thought that okay, he gave now the whole complete source code of the Linux, right? He gave under the Free Software Foundation or or into the or into GNU organization. See now, everything was there, sir. One thing was missing, which was nothing but Linux. Now this also got fulfilled, right? So what Linus Torvalds did that in 1992, Linux was evolved or Linux was released. Okay, and what Linus Torvalds did, right? Torvalds, Linus, he released the kernel version of Linux operating system 1.1. First release, he released the first kernel version 1.1. Okay, and Linus Torvalds is the same guy who maintained his own site. We call it the kernel.org. You could see that all the kernel source code will be there in the kernel.org. So many people still go to that site. They want to download any kernel source code, they'll go to the kernel.org, guys, like this. See, you'll find all kernel version. Now you could see that it is a 5.8. Now, so what happened, right? 1.1 was there in the 1992. Slowly 2. Series came, 2.1, 2.2, 2.4, 2.6, 2.8 came. Then afterwards 3. Series came. Then 4. Series came. Now it is 5. Series. Now, what Linus did, right? Linus Torvalds, he started, right? He is a main maintainer of the Linux kernel till up to some years. Like from last, if I'm not wrong, from the last 10 years, he's not the maintainer now. Before 10 years, right? Like this is 2022. I think if I'm not wrong, till 2010, he was the maintainer actually, 10 to 12 years back. Now what happened that he has given this maintainer to many other people actually. One of the key contributor is a Craig Koch Hatchman. He is a main maintainer now for the Linux kernel. It means that earlier they used to take approval for any kind of a kernel release from Linus Torvalds itself. Finally, Linus Torvalds has to approve. Once he approves, that particular kernel will get uploaded into the kernel.org. But now it is a Greg who is actually maintaining this kernel, and he's uploading the code. He will sign off. He's a person who will sign off for any kind of a new kernel version release. Sign off. And The pattern is actually what happened, right? Every 6 months, they will release a new kernel actually. So in the kernel.org, you could see that every 6 months a new kernel is getting released, right? So that's how this kernel came into the picture. Linux kernel came into the picture. Okay. Now what happened? Now many of the organization, software distribution organization, what they saw that under the GN organization, lot of tools, compilers were there. Only one thing was missing, which is Linux operating system, which later in 1992 was fulfilled by Linus Torvalds. Now what many giant companies they did, okay. One of the first software distribution for Linux was a Slackware, sir. So what are the distributions? Many giant distribution. One was a company by name Slackware. I think this company is basically from Italy. Okay. What they did, right? They saw that the complete stuff is free. Linux is free, libraries are there, tools are there, bash shell is there, compiler is there, blah blah. So many things are there. What this company did now, Slackware, they took the complete thing, they tweaked into certain things in the Linux kernel, they tweaked certain things, they added their own additional softwares and server softwares, and they started releasing the Linux. Okay. To the universities, to the colleges, to the companies and all. They started selling it. But this Slackware, it didn't go for a very long time because like a very giant distribution which came into the picture was the Red Hat actually, right? Red Hat is a very great organization which came to the picture. What these people did, Red Hat, they started taking all the things. What the major thing, what Red Hat did, right? They took the Linux kernel, they tweaked a lot, they tweaked a lot into the kernel to support the servers. Like for example, DNS server, NFS server, NIS server, Samba server, Skip server. I was telling you earlier, right? There are many servers are there, right? So what happened? This Red Hat, it becomes a server software release actually. It means that they are very good at server software. It means that suppose some company needs some XYZ company there. He said that actually I want to configure all kind of servers, or I need a DNS server, NFS server, NIS server. What Red Hat will say that, sir, take it from us that software. That's a Red Hat only. That's a Red Hat Linux only. It's a Linux only, but we support the server edition. So anybody is willing, please take our server editions. Okay. And what they did, right? Red Hat, they initially released with the name Red Hat actually. Red Hat 1, Red Hat 2, Red Hat 3, Red Hat 4, like that. Up to Red Hat 9 was there. 1 to up to 9. Okay. In if I'm not wrong, in 2002, Red Hat 9 was there actually. Red Hat 9 was there. Later, what happened, right? What Red Hat did, right? They renamed this Red Hat to RHEL. RHEL. RHEL is an enterprise actually. It means that you need to pay the money for the licensing cost. The enterprise version, it means that you need to pay the money. Okay, you have RHL1, RHL2, RHL3, 4, 5, 6, 7, 8, 9, like that. So many versions are there. Many of the companies are still using RHL7 and RHL9, right? 8 and 9. So RHL7 or RHL6 is still used in many of the companies, right? And this RHL is not but Red Hat Enterprise Linux. RHL means Red Hat Enterprise Linux. These are favorable for the server editions. Whenever you need any kind of a servers, Red Hat are the best company to provide the server editions actually. It means that any company needs any kind of a server setup, oh, you please buy the RHL, sir. This RHL will support everything. Similarly, what happened in the Red Hat, actually in the Red Hat organization, there's one more sub organization they created, which they call the Fedora. It is like kind of open source. Okay, Fedora. And Fedora also had a release, Fedora 1, Fedora 2, Fedora 3, Fedora 4, Fedora 5, like that, Fedora 6, 7, 8, 9. So now, so it is a version actually. Again, why they're doing this, Red Hat itself, it's internally Red Hat, why they're having Fedora, because, right? So what they'll do now, they will try to release the software freely for the free Red Hat Fedora. What people will do all over the globe, they'll try to download for the Fedora, they'll try to install it in a system, they'll try to work on it, they find some flaws or bug in that, and they will report that bug to the Red Hat only. What Red Hat will do, they will take that consideration of all the flaws, they'll try to fix it, and they will try to make sure that when they're releasing RHEL, right, that should not have that bug. It is something like they are doing a free service so that they can get all kind of a bugs, right? Of course, they have their own engineers who will find the bug, but there are many other outsiders are there who will be actively working on Fedora, right? Active working on Fedora, they will find all kind of a new bugs in the new kernel release or the new Fedora release, and they'll try to write or they'll try to submit all those bugs into the Red Hat actually. So by that, Red Hat are nothing but they're easily getting all those bugs, right, without paying any money, right? So that is one of the intention of Red Hat. That's the reason they are maintaining this Fedora project also within them. They have not stopped it. Okay, but still RHL is most favorable. So Red Hat became a very big organization, and you know that Red Hat is acquired by IBM now, right? 4 years back, Red Hat acquired IBM now. Not sorry, IBM acquired Red Hat. Okay, so after that, Red Hat, there were many other organizations are there, distributions are there. Like for example, you have a SUSE. SUSE is from Europe. Basically, it is from Germany. They have the SUSE distribution. What else you have? You have a Ubuntu. Right? Ubuntu is a very, very famous distribution. Many of them today people are using Ubuntu. Even in industries also they are using Ubuntu distribution itself. So Ubuntu is also supporting a server edition. Means that you want to install any kind of a server, DNS, NFS server, NF server, Samba server, Squid server, Mail server, proxy server. You can go with the Ubuntu server editions. It's a paid one actually, right? So and also it has an open source also. Anyone want to download Ubuntu and install the ISO image in your machine? Yes, it supports it actually. So both are there. So Ubuntu was started by a person by name Mark Shuttleworth actually. By profession, he's an astronaut. Okay. Later, he found this organization known as a Ubuntu organization. Basically, it is from some South Africa. This organization is in South Africa actually. And what Mark Shuttleworth says actually that I want to see that someday this Windows operating system should completely get wiped out from this earth. Nobody should use Windows operating system in their office, at their home, or any kind of organization. They should not use. They should only use a Linux operating system. That too, they should use only Ubuntu. That was his thinking actually. But of course, till this earth is there, till we are there, Windows will be used, Windows will be there. But he said that, oh, I need to see someday where Windows should not be used by anyone in the world. So that's the reason he started this Ubuntu organization. So Ubuntu, you know very well, it is very, very famous distribution. Of course, many people around the world, particularly, I want to tell you that many people who are working in embedded level, right? Embedded level, they are using Ubuntu only. They are not using Red Hat. They are not using Slackware. They are not using any kind of other distribution. They are only using Ubuntu distribution because the support of this Ubuntu is extraordinary, sir. Actually, it's a support is extraordinary. People are nicely heavily using Ubuntu in embedded world, and the whole development activity on embedded, right? There are many from small company to the very large big companies, embedded companies, right? They are using Ubuntu itself. So Ubuntu is very, very, very favorable when it comes to the Linux distribution. So I would prefer that Ubuntu or Red Hat, you can go with that. Okay. So in our classes, whatever we are learning in upcoming, we will try to stick to Red Hat itself. Red Hat. So I'll be using RHL 7 only in my class. Okay. Sometime I might show some difference between RHL 7 to Ubuntu. At the time, I will launch the Ubuntu servers and I'll show a comparison between what is RHL and Ubuntu at the time. Okay, so like that, there are many other distributions are there, Ubuntu, and you have heard about Knoppix. The list is very huge, sir, right? Knoppix, like that. So the list is very huge. One, two, three, four, five. Sorry, five. The list is really Bluefish, Bluecat. There are many other distributions are there which are used, but yes, most probably many of the companies are still using SUSE. Many of the 70 to 80% companies are using Red Hat, and some 30 to 40% companies are using Ubuntu, like that. It depends upon your requirement. You go and choose that particular distribution to install Linux, right? So what again, even today also, it could be Ubuntu or it could be Red Hat or it could be any other distribution. Still, they are depending upon the Linux new kernel version. So whenever the Linux new kernel version is released, once in 6 months, right? All these companies, Red Hat, SUSE, Ubuntu, or any other companies, they'll try to download the source code from the kernel, and they'll see how things works. What are the new feature which is there in the kernel? Whether it is applicable so that we can use this new kernel and we can give as a distribution to the other companies, right? They'll start working on it heavily. It means that whatever the products which are running under this Ubuntu or in Red Hat, whether it will work in this new kernel, that's what they'll be doing heavy testing. So that's what they'll be keep watching this kernel.org. They will get the notification early only, sir, when the kernel will get released. Or tomorrow, if this get released, they will be ready by today only. So once the release get happens, right, they will try to download it. They'll try to go to the document, internal documentation of the kernel.org. There they've written, right, oh, what are the bugs which have been fixed over here? Okay, what are the new enhancements I've done? What are the new different device drivers have been added into it? If there is any flaw, if there is any bug, who has raised it, how they have rectified it, every minute detail. This kernel.org, they will maintain everything in the documentation, right? So that's how it comes. That's how they try to work on the new releases. Clear, guys? I hope that I have took a very lengthy discussion on this, but you have understood the heart of the complete thing, right? Any doubts
Yes.
or anything is there? It's only theory, nothing there. Yeah, nothing. Just you have to listen like a theory. That's all. But this is required actually. We should know. Suppose somebody
Yes.
today, if somebody asks you who is Richard Stallman, hey, the person who key the term open source. Oh, he is, man. He is a Linux. He is a Richard Stallman. Okay, who is Linux Torvalds? Oh, the same person who designed the Linux kernel, or the same person who designed the Git, Git tool, Git, right? He's the same guy who designed the Git also, right? He's a contributor. He is a main innovator of your Git or the Linux kernel. Like that, you should know. Of course, there are many other people are there, sir, who are contributors, right? So that's what it is, sir. Okay. Okay. Now, so now what uh, Linux did, right? Linus Torvalds did. He released the 1.0.0 version. 1.0.0 version he released. Suppose you have logged into a system, Linux system, you want to see what is the kernel version, you have to execute a command uname-r. This is the command. We will see later all this thing. Command to check the kernel version. Clear, guys? Now, now of course it is now there's a 5 dot series like this will be there. Now earlier, okay, you know that I told you that 1 dot series, 2 dot series, 3 dot series, but the most famous which I saw in my life was a 2 dot series, sir. Lot of people were heavily using 2 dot series. I even remember that some people were using this kernel on it. 2.4 dot 2.4 dot 18.0. 2 dot not 2.4. Yeah, 2.4, 2.66 dot 36.0. These were the famous kernel versions which I have come across life, which many companies were stable using for very long time. They didn't move. Suppose some companies using 2.4 kernel, their application is working on the 2.4.18 kernel. They're very much hesitant to go or move to the 2.6 kernel or 3.0 or 4.0 because their whole application is working right comfortably. They don't have any issues. Even customers are not facing any issues. Why we need to migrate? If you migrate means you have to face a lot of challenges. That is the thing, and nobody want to face the challenges, right? Usually what happens, right, whenever any company they release a product, they'll make sure that my product should work onto the particular environment or particular operating system in a very comfortable manner. So my product should not be any kind of a it should not show any kind of a sorry, it should not show any kind of a issue in the customer site or into the customer location, right? That is the main intention of every company, right? So most of the products were actually designed or were working comfortable in this kernel. But what happened, right? If a customer needs a new features into their product or into their application, of course, these companies have to get into the new kernel version. Without that, they will not be able to explore what are the changes are happening. So obviously, many of the companies earlier the product was working on 2.8, 2.6 kernel. Later they moved to 2.8 kernel. Now the product they have migrated to 5.0 kernel also, right? So that is also timely time required actually. So who will who will do this migration and all? Usually the developer will do. You need not to worry about this. As a DevOps engineer, we need not to worry. Only the developer will see that. So that the requirement will come for the developer. He will say the product no, the product architect or the project manager, or he will come and he will say, boss, this application working on so and so kernel version, but we need to migrate because there's a customer requirement for that. Because why is a customer requirement? Because customer has seen that there is some new feature it has come in this 5. Series, but our product is running in 4. Kernel. So in the 4.0 kernel, that feature is not there. It is there in 5.0 kernel. So what you do, whatever your product or the application which is running in 4.2, please migrate to 5.0 kernel. So the developer will understand, he'll get into the 5.0 kernel, he'll understand what are the new features are there. Okay, what are the tweak I need to do to my application so that it works on 5.0, that and all he will understand. He'll try to migrate that application from 4.0 to 5. Series, like that. Okay, even every day they'll be doing like that, sir. In every company, in every product based company or anywhere, you see that they'll be keep migrating their application from one kernel version to the other kernel version. Okay, but this were one of some of the famous stabilized kernel version which many of the companies were using at that time. Okay, now of course now they have been migrated to the latest version only, but this is the version actually. So there is some representation. You could see that there's one dot is there, one number, numerical number, there's a dot, again there's a numerical number, there's a dot, again there's a numerical number. What this signifies actually? Suppose if I say 2.6.36.0 hyphen hyphen, like this is there. So what it says that actually that this is the thing, but this is the major number. Sorry, this is the major number or major version, you can say. And the second after this dot, no, the second is nothing but it is a minor version. And this is a patch level. And after this patch level, whatever hyphen dot zero blah blah hyphen with hyphen, no, this we call it as an extra version actually. This is the naming convention. Okay. 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 Now, major version. Suppose what happened, right? If there's a drastic change in the kernel itself, if the Linux torvalds, if you understand, okay, from 2.0 version, I need to migrate to 3.0 version. If Linux torvalds think that okay, whatever the kernel version which is doing, I want to do a drastic change in the kernel version, lot of changes to the kernel version, then Linux torvalds thought that let me release with a new version, right? Suppose he is working on 2.0, he thinks that I need to do lot of changes in it. He will not release in 2.2. He thinks that no, I want to release in 3. Series. Oh, he will release it. So whenever there is a lot of changes which is there happening in the kernel itself, then Linus Torvalds or his teammates they'll tend to increase this major number. From you could see the series is 1, 2, 3, 4, and it has not happened, sir. It's not happened drastically, sir. From 1. Series to the 2. Series, right? The gap, if you see, right, it is near around 6 to 7 years. There's a gap. It means that first 1.1 was released, then 1.2 was released, then 1.4 was released, then 1.6 was released, then 1.8 was released. Okay, now finally they said, okay, now we will not continue with 1.10, 1.12. Oh, now we will release with the 2 version. Then the user releasing the 2 version. Now again 2.1 or 2. Not 2.1 actually, 2.0, 2.2, 2.4, 2.8, 6, sorry, 2.8. Now they thought, no, now I will not give 2.10, 2.12. Oh, let me give you the 3 release actually, like that. You got it? Now what happened, right? When they saw that they were doing major, major stuff in the Linux kernel, then only they tend to increase the major number. That's what the major number is. Minor number will tell you whether it is a stable kernel or an unstable kernel. Okay, if the minor number is an odd number, it means that it is a unstable kernel. Like for example 2.3 version, kernel version 2.5. See, the minor number is an odd number, 2, 1, 3, 5, 7, 9. These are odd numbers, right? These are unstable kernel. They are used for experimental purposes. Experimental purposes. They're used for experimental purpose. Whenever the minor number is an even number, it is a stable kernel. So minor version is a even. Here you could see that 2.6 is a minor version. Is 2.6, it's an even number. 2.2, 2.2, 2 is a even number. 2.4 is a even number. So those are stable kernel. So these kernels can be used. They can be used in production environment. You cannot use the 2.3, 2.5 in the production environment, sir, because it has a lot of flaws. They are used for experimental purposes. That's what it is. So you could see that whenever you could even see in the Kannada.org, all these are 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. 2.0, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, like that. You can see all numbers, but only when they are even number, those are stable kernel. Whenever there's an odd number, it's an unstable kernel. You have to. Even for the 5. Series, you have 5.1, 5.2, 5.3, 5.4, 5.5, like that. You need not to download 5.3 and 5.5. No, those are unstable kernels. They are used for experimental purposes. Okay. After that, patch level. Now, for example, what is a patch level? Like, for example, you have this kernel 2.6.26-0 kernel. This is the kernel version you're having, sir. Suppose somebody says tomorrow, hey, Rajesh, this kernel version, does it supports for KDB? What is this KDB? We don't want to learn, we need not to understand, but you have to just understand, okay, KDB is kernel debugger. Hey, does it support for the kernel debugger? Whether this kernel supports, I will say no. Okay. What that person will say, go to one thing, go to the SGX site, go to SGX site, download two patches from there, from there, and install these two patches to your Linux 2.6.26.0 kernel. It means that you need to go to that site, download those two patches, install or patch these two patches into this Linux kernel, so that now your kernel will support KDB, something like that. Okay. So as an engineer, what will you do? You'll go to the SGX site, go download those patches, attach or add those two patches or patch it. What is patching? Later I will tell you. Okay, you'll patch it. Now what happened, right? What you'll tend to do, now it was 2.6.26. Now what you'll rename, you will say 2.6.28, because you added the two patches. This patch level should get increased from 26 to 28. You have to do like this. Clear, sir? Is it clear? Patch level. Guys, did you understand what is a patch level? Already this version is there. Now, tomorrow you'll say that Rajesh, 2.6.28, okay, you added two patch. I want to add 5 more patch. Please add the 5 more patch to 2.6.28, but please increase the patch level so that you'll get to know that, okay, so many number of patches have been added. So whenever there's a bug, actually, what the people will do, people will release a patch, and that patch has to be added, or it has to be patched up with the existing kernel version. While adding it, what you will do that you will tend to increase this patch level. That's all. Okay, sir. It should be very simple. If anyone asks what is the third representation of the kernel version, this always represents it's a patch level, sir. That's all. So whenever any new patch is getting added, this value will get increased. That's what you have to say. And this extra version with a hyphen. Yes, sir. Let me know if you have any doubts. No?
No, Rajesh.
Great,
This
sir.
looks good.
Yeah. Now extra level, extra version. Extra version is something that, suppose you are having same kernel with a different configuration, is identified by the human with the help of extra version. I repeat it. Extra version, the same kernel version with the different configuration is identified by the end user by the help of extra version. Suppose, for example, I'll take the same kernel 2.6.28. Sorry, here I'll say 2.6.26, not 26, 26 hyphen O, like this. Same kernel. This kernel is there. Assume that this kernel or this operating system or the kernel is not supporting the PFAT or NTFS file system. Assume that it is not supporting. It means that you don't have this file system support at all. Right? Then what you will do, guys, you will try to, what you do, right? you download NTFS file system and get it integrated with the 2.6.26 kernel. You get integrated. You'll add that model, okay, VFAT or NTFS model. You add it. Now, once you add it, okay, to make it to effect, to make sure that your kernel should support, what you have to do now as a user, you need to do a kernel recompiling. You need to do a kernel recompilation. So this you need not to understand very well, but you have to just understand that whenever I'm adding any new extra feature into the existing kernel, always you need to recompile the kernel. There are different steps to recompile the kernel also. Okay, is it required for us to know? Not required. Okay, assume that I'm just telling you one information. Assume that some engineer, DevOps engineer, see guys, some DevOps engineer, he's working in a company, it's an ARM company. He's working on Emulix company. Some engineers, I'm saying. Suppose some engineers are working in Intel company, right? These are all some product-based company or some companies or some person who is working on not on networking company and all. What they'll do, right? They will always they want to add some extra features into a running kernel or into a running operating system. So what the DevOps engineer will do, he will either patch the thing, patch or add the feature into the running machine or into the running kernel or into the existing kernel, not running into the existing kernel. So after that, what the DevOps engineer is supposed to do, right? He's supposed to do a recompiling the kernel actually. He need to do a recompiling of the kernel. He has to do recompiling. That is his day-to-day activity. So there are DevOps engineers who are working in these companies where they are working. So this DevOps engineer, no, see, you know that maximum most of the DevOps engineer where you're seeing where there is kind of a web development, right? Where there are applications which are developed in .NET, where are developed in Java, right? You need to you need to work as a DevOps engineer to deploy your Java applications or your Node.js application or your .NET application into the servers, right? That's what you have been keep seeing. But you don't know that you might not come across that there are so many DevOps engineers are there who are working in a product level company where they are corely working on on some embedded platforms. So there also DevOps engineers are used. But this DevOps engineer who is working here, he might have some good knowledge, some knowledge he will have on C language. He will have some knowledge on make files, how to work make files. And also he has some knowledge on operating system also. Very good knowledge on operating system. As well as he will have some knowledge on networking, very good networking. He'll have some knowledge on storages like this. So the people who are having this kind of a knowledge, right? He will be perfectly fit into work in this company, and it's a very highly paid job actually. Okay, highly paid job. There, what he has to do, right? As a DevOps engineer, he has to add the patch, add the feature to an existing kernel, and then he need to recompile the kernel. So what he will run the step? No, either he might be following a document to recompile the kernel, or else he might have written a script so that he will run an automation like that. So he will say like this: make is that image. You might not know all these things. Make models, make models underscore install, make install. Like this, there are some set of commands. These are the commands which are used to recompile the kernel, Linux kernel, sir. Okay. So that's what there in those companies, where the DevOps engineers are there, they will be knowing all these things. Sir. They will be knowing many things about the operating system also. So for them, they never interact with any kind of web application. So these companies, ARM company, do you think that they will develop on applications? They might work, but there's a different section altogether. There's a different department altogether is there. But you could see that they are mostly working on some kind of hardware. ARM process is there, right? ARM company is there, like that. Emulix company is there who are heavily working on storages. They are there, right? There is an Intel company, who are working on it. There also a lot of DevOps engineers which they play a vital role in a day-to-day activity, right? Even they might also use the Jenkins also to do all this in a pipeline, right? Into a CI/CD pipeline, they will be using Jenkins also or some other tool they'll be using. But mostly what happens, they'll be playing with this make files, C files, and all they'll be playing, and they'll be playing heavily on the OS and networking concept also like this. So that's the reason, right? Some people. So here, coming back to here, Okay, so you need to do a recompiling kernel because you have added this NTFS file system module into this kernel. Now we're recompiling the kernel. What will be the kernel version now? 2.6.26 hyphen NTFS, like this will give. So this kernel 2.6.26.0 and 2.6.2.26 hyphen kernel hyphen NTFS kernel, both these kernels are same. Only one difference is that actually this kernel will support for NTFS and this kernel doesn't support for the NTFS. So what the extra version I said, the same kernel with a different configuration is identified by the human by the extra version. So here, whenever you see this kernel, oh, you'll understand. Okay, man, this kernel will support NTFS. Okay. Oh, this kernel, oh, it might not be supporting NTFS. Like that, you'll come to know with the help of an extra version. Is it clear, sir? Sir, is it clear? I know for some of
Yes,
you,
sir.
some of you, it might be looking very, very, not very, it might be looking little confusing, little difficult to understand, right? But no problem. No, that's fine. You have to just move on. You have to just understand the concept and move on it. Later, everything will be clarified in upcoming classes.
Yeah, Rajesh.
Okay. So now, see, you understood not whatever I'm saying, right? How I'm saying all these things. No, I know one of few of my friends who are working in these companies as a DevOps engineer. Because when they share the information with me, right, this is how Rajesh I'm using make files and all to compile the programs and all, right? I need to build the whole product like that. So they will be using a lot of tools also. They will be using, and also like many of these companies are still using Docker also. They're using, sir. They are using Kubernetes also. But what happened? Everything they are not into the kind of a web development, right? They are into some kind of a system level products they are building. For the system level product support, building and all also, you need DevOps tools. For that, they are playing a very vital role. Got it? But for them, they need to have all this knowledge on C, knowledge on operating system, knowledge on make files, knowledge on networking, knowledge on storage is required for them.
Yeah.
Okay, fine. So that is all about the kernel version, sir, release. So what we will do, we will stop the sessions now because it's already 1:20, 1 hour 20 minutes we have recorded. So what we're going to